club where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello and welcome, everybody. It is March the 4th, and we are cruising on our way through the year. We are on lesson 26. Make sure I share the right screen with you all. We are on lesson 26 and talking about accumulated change, which is our nice approachable name for integral calculus. So as we start every week, we talk about some strategies for flashcards. And especially as we're getting toward the end of the year, it's a good reminder to celebrate the things that we know. And that can take the form of woohoo celebration. Let's go eat ice cream, although I'm trying to do a better job of not always celebrating with food, not treating food like it's a reward. But whatever your reward of choice is, I think that there is a place for celebrating that your hard work has paid off and you have accomplished something to recognize that. But celebrating the cards that are mastered can also mean that we continue to practice those, right? And that instead of always just facing the hard cards that we're still struggling to get, that we don't always remember, keeping those cards that are familiar, right? Having those come up, right? You go, oh, I know this one. And so there's a sense of accomplishment and a celebration that there's something that's inherent in just going, oh, here's something familiar, that then encourages us to keep going with the others. So it's not necessarily just a separate celebration that you've learned something, but it's that ongoing, right? Keeping things that are familiar as a part of your review to build your confidence that the process is working and that you are learning. Does anybody have anything they'd like to share about flashcards this week?
It's a good reminder about the celebrating because I think sometimes we have really hard days, and maybe I should just pull out the ones I know they know, that I know that they've mastered to give them some confidence. Because there's just some days, I don't know, it's just the way you wake up. It's like nothing is going right. You're struggling with everything that's going on. And so I don't think it's trickery to let them see that they've mastered 30 cards out of the deck. I mean, so I think that's a great reminder that we could pull that out, and especially on those days where it just seems like we need more encouragement.
That is really great, Babs. It makes me think of Kate yesterday was having a rough day, saying nothing seemed to be going well, and she was just didn't really want to go to her class. And she walked into her class yesterday afternoon, and her teacher gave her a hug. Um, I just want to give a shout out. I'm so thankful to the professors that she's had at PBA, that they truly do pray for them and have sought relationship with them, which has been really beautiful. And she just said, Mom, that changed the whole day, right? That those small things have the potential to change our whole day. So it could be letting our students have a moment where they go, hey, I know this, instead of struggling. Or it may be a hug, or it may be, going to the gym and getting your frustrations out. So,
I
but yeah,
think
I think that's a great reminder.
one of the things I was thinking about this week with regard to the flashcards is setting up another memory box. We still have memory boxes for our foundations memory work. And I'm like Babs getting over my, oh, I gotta take the cards out of the boxes and mix them all up thing. But I actually did start thinking about how to do that. And in that memory box way, there's always a section of mastery. And the ones that, we master and we still go through them, but we just don't go through them as frequently as we do the new stuff that we're learning. So I'm kind of thinking through how to because there's still notations that I don't know, and terms, and then with two new boxes coming in. So
Yeah, that's great. And just that reminder that we have to keep practicing. In Bible study last night, we were talking about um, knowing the books of the Bible, right? Um, and I said, well, we sang a song, and the ladies were kind of looking at me, so I started singing Genesis, Exodus, Leviticus, which was a CC song, right? That we learned. That was one of the first things that we did, and I still remember because we practiced and practiced, and because I continue to practice, right? And so that idea of celebration um, is also a reminder to continue to practice because things can sort of shift back, right? We can have things really firmly put in our memory so we know that they're there, but if we don't sort of continually bring them to the front, they'll sift down and it'll be sort of harder to dig for them. And so helping our students to remember that will keep those things forward in our minds. Looking at our cover, as we think about our 15 skills, I pulled forth our canons of rhetoric this week. And Memoria is always just a great time to talk about memories. Right? What memories does the artwork bring to mind? If your family's been using the math map for a little while, you might have memories that are specifically related to this lesson. They may say, oh, I remember last year I learned, or this was about this idea, or it looked like Riemann sums. But even if you haven't, right, just looking at that picture, if you've ever been outside, there's something in that picture that you can remember. And so encouraging our students to use that as a hint or a sort of an encouragement to think back and remember. When we think about invention, I was brought to mind the idea of creation versus invention, and creation tending to be something that's entirely new. In our modern parlance, we tend to think of it as something artistic. But when we think of creation as being something that's entirely new, invention can be new, but it has that sense of using what we already have. So when we invent, we often start with an inventory of what we have. So when we look at our artwork, we can think about, does it show creation? Does it show invention? Does it show both? I think about the Central Park picture, that piece of art, and you could certainly see aspects of creation there. But then there's also wheels and wagons that are moving, halters on the horses, there's benches. One could argue that those are inventions. So talking with our students about the artwork and where does it show creation or invention. Always, even though we're getting close to the end of the year, it's always a good idea to review the arrangement of the page, to take time and say, what dimension are we in? What lesson are we on? What domain are we in? What's our lesson title? What are the things we could talk about? The art, the quotation, and the reflection. And helping students to see that those are the same elements on each of the lessons. The only thing that's different is the title of the domain and the color that they're in. And I don't really have an answer for this question, but I thought it was kind of a fun question to think about the visual equivalents for our elocution elements. So usually when we think of elocution, for example, alliteration, it's literary, it's using words. What would be some things that might be visual? Right? When we look at art, what kinds of things might give us a hint of alliteration? Anybody have any ideas?
Well, alliteration is always beginning with the first sound. So it's just a repetitive process. So like this picture makes me think of that it's repeated in height at the top here. It's repeated through the middle. It's all lines. So to me, that would be a visual equivalent to alliteration.
Like that?
Mhm. There's something about repetition, like
Mhm.
literary alliteration that breeds familiarity. So I like, when I look at the cover, the MathMat logo is always going to be at the bottom right. And if I were to encounter another booklet that's pirated in from China or someplace, and the MathMat logo is slightly off or to the left-hand side, immediately my mind would go, wait, it doesn't fit the alliteration or so.
That's a good example. The other thing would be like if you're making a rose window or a mandala or some sort of pattern that repeats itself.
Mm-hmm. So your mind was certainly count like, oh, something is really off. You can't quite pinpoint what it is, but because of the other alliteration pattern, you know that something is off.
Yeah, I think it would be fun. We could spend a whole hour just talking about all the different elements of elocution, right? So, and what would they look like visually versus orally with our ears? That might help our students. I was just thinking, I wonder if that would be a great conversation to have with students who tend to be more visual than oral, that if they're struggling with some of those elements that you hear, asking them, well, what would it look like, and see how they may visualize that differently. And then for our delivery question, always asking about the medium of the artwork is a great delivery question, right? That we sometimes have had photographs, we have had some things that were paintings, some things that were drawings. I think there's been some elements where we saw the gold foil in the art, if I'm remembering correctly. So we've had a lot of different types of medium or media that the artists have worked with that we can talk about with our students. Is there anything anybody else would like to share about the artwork or the covers? I always think we tend to go for the visual, for the artwork first, because it's so inviting, but it's always just want to take that time to remind you that the quotations and the reflections are there also. So for those students who perhaps are less visual and more literary minded, this may be a time to read those aloud. And that's a way that you can tailor that experience of the cover to each of your students to meet them where perhaps they're going to interact with it in the most hospitable way.
And just as an encouragement to remember the quotes and the scripture and the prayer, this week, one of our testimonies was from a mom, and all they did was talk about the quote. And I think it was a prayer from one of the, like it was St. Francis of Assisi, maybe. And she led her daughter to Christ just after talking through the quote or the prayer that was on the cover. And so I mean, that's just a great reminder to not forget that those are there and that they can be, useful to find that connection.
Always beautiful to hear those stories. I enjoyed reading that one. On our first day of the week, we encourage you to take time for the map itself, recognizing your domain and your week. So here we are. Notice we are finishing up 4D. It's gone by quickly. We spend a lot of time in 2D, and then our 3D, 4D, and ND lessons all go by fairly quickly. But this is always a great reminder to circle back and have those dimensional conversations with your students to say, okay, what were the dimensions? What are some patterns that we've noticed? And you can use the math map to help you do that just by looking here and saying, okay, well, we had how many lines? None. There was just a dot, one line. We had 2 lines. We had 3 lines. We've got this weird shape that's trying to show us 4 lines. And so looking at those patterns there as we encounter them is a great opportunity when we start or end each of the dimensions to remind them of those patterns that they're seeing. And then that brings us to our lesson pages. And so our strategies for the lesson pages today is to match the lesson pages to the charts. We've repeatedly said that for younger students, the charts tend to be a resource more geared to parents to help them see where the work that their younger students are working is tied into the bigger picture of mathematics. It becomes more of a resource for our parents. For our older students, we hope that they are starting to lean into the charts and see those as a resource for them. But as a family looking at this together, what are some ways you could do that? And I thought there's really two situations. You can have students who are very familiar with the lesson pages, and you can have students who are less familiar. If they're familiar with the lesson pages, especially if they're a very confident student, right? And Yating, I don't know why I always think of you, but I always think you've got students who seem to be self-confident and think that they've got a lot of things knocked out. And so
You mean
how do
wise
we
in their own eyes? I think it's more like that. But go ahead, I'm sorry.
no, yeah, that's, I always try to put it in a very, encouraging way. We do have those students, right? They think I've got this. And so for those students, how do we either give them a check, or how do we give them a way to press on without just pressing further? Um, I
Yeah.
remember from my days classroom teaching that if a student was doing well, it usually meant they were picking up on the algorithms, they were seeing the patterns, but they weren't really understanding. But the response of the system and of, frankly, most parents was just to say, well, they're really smart. Let's push them to the next book. Let's push them to the next class. And even if you said, I don't think they're really ready for that next class or that next book, the parents would insist, no, they really are. And then they would get there and they may stumble or not do as well. Or even if they did well, they didn't necessarily understand because they were just really great at finding those patterns. For those students, how do we engage them without just saying, okay, great, you saw the pattern, keep moving ahead without ever stopping and slowing down? And I think encouraging them to look at the charts is a way to slow them down and say, do you really understand this? Or are you just noticing the patterns? And I don't want to say just, because that's what we're doing. The whole goal is to notice the patterns, but there's a difference between noticing that the pattern is 2, 4, 6, 8, and they go, oh, well, the next one is 10, right? 12, and they can finish the pattern. There's a difference between being able to follow a pattern and come back and go, oh, wait, the pattern is that they're adding 2 every time. And that's actually a pattern that is an arithmetic pattern, right? Notice that we can take that pattern and we can understand it at different depths there versus just completing it. And so for those students who are seeing patterns and starting to complete them, having them take those concepts that they're seeing and then find those in the chart is going to help slow them down a little bit and encourage them to think a little bit more deeply. They can
And
see.
I started to ask the person who is intuitive to see the pattern, the next number, to explain to me, the poor mother who don't understand, tell me why is it the next number. So I think, when we tutor the master students in foundation, sometimes we have them be the tutor, and there's the next level of understanding when you can articulate your thought process. And so that's something that I asked him to do. I'll kind of act that I don't really know what I'm doing, and so he would teach me.
That's perfect. No,
Sometimes I'll shoot myself in the foot.
so that's what we're talking about, is those students, giving them those opportunities that if they can't articulate, right, say, okay, well, go look at the chart, find this concept in the chart, see how it fits into the map, or go look at the chart and see how this particular concept links to something else. Or, okay, you zoomed through this and you got this, well, go find something that maybe we should study a little bit more deeply. So those are our familiar students. And I don't want to say older, right, or younger, or better or worse. It's really the students who are just becoming more familiar with the concepts, the ones that maybe are ready to hang a little bit more on those pegs. For the students who are less familiar, the charts may become a resource for definitions, for formulas, or for examples. And so those are some ways that we can utilize the charts with our lesson pages with our students. So that was our strategy for this week. And then here is a picture of day one. And if you were with us last week, do these pages look a little bit familiar to you? And what looks familiar?
Did we have the ant last week?
Mm-hmm.
I was going to say the ant walking along, but the line, the ant, wasn't there more than one ant last week?
There may have been. I don't remember without going and looking.
The column down the
More on the
side with
lower, more on the lower grades whenever there's a couple of points they're looking at.
Yes, Jana, good. So the column down the right-hand side is very familiar to us. Almost the same. One box is different. So we see as we look here that we've got a graph at the top, and we might notice that these are the same graphs that we had started with the constant function y equals 1. Last week, we're starting with the constant function y equals 1. This week, we see that on the right-hand side, we have those same similar boxes that we're still talking about the function, the derivative, the inverse, and a translation. This week, instead of talking about whether or not it is differentiable, we're just looking at the integral function. We're just becoming familiar. And we see a similar building of the work involved from left to right as we're working towards this. Last week, we were talking about slope. Just looking at the images this week, filled boxes, any idea what we're talking about this week?
You mean the concept, the math concept, like last week was
Yes.
slope and this
Yep.
week is area?
Area,
what
that's
you mean?
perfect. Yep. So without really knowing a lot about calculus, but last week we emphasized over and over that the derivative is going to give us a slope. And this week we see that we're talking about integrals, accumulated change, so we're adding things up. And when we look at our integrals, we're talking about area. So that's the big idea. And I think that there's a lot of students who perhaps leave calculus class without ever really internalizing that. And so if we can, even with our youngest students, connect the idea of the derivative with slope and the integral with area, we're already starting them on a path towards understanding that's going to build over the years.
Kirsty, Andy wanted you to read where it says on the first page, copy, and it has the equation. Can you read what that's supposed to, how you would read it?
Sure. So on the left-hand side with the integers, I would read that as the integral 1 times the 0th power of x dx. Or you instead of dx, you can say with respect to x equals the first power of x over 1 plus 0 times c. To the right of that, we see that we have the f of x, or capital F of x, the antiderivative, is equal to the integral from a to b, I think that says a to b, of f of x, or the function of x dx, or with respect to x. So then I could read the integral from 0 to 4 of 1 times the 0th power x with respect to x equals 1 times the first power of x over 1 evaluated from between 0 and 4. So there's a lot of words there and some options there, but hopefully that helps to see how we could read those. On day 2, we take a look at our I-squared invention page, and we continue to harp on the fact that this is a page to practice the common topics of invention. So this week's common topic is relationship. And if we've been paying attention throughout the year, we might notice that there is a familiar order on the page. I think last week somebody mentioned that the order was familiar to them. They said, oh, we talked about these, right? We've seen this list before in lesson 11, in lesson 17, lesson 13, lesson 18, I think, and then lesson 25, now lesson 26, lesson 30. We're seeing the same list of functions over and over again. And so we can talk about the order that they're in. We could also talk with our students, not dependent on the math, but what hints can we use to examine order? Right? What direction do we usually read? From left to right.
Right.
Or and top to bottom, right? So if I said, what's the first thing on the page, where would your eye normally go to?
We'll go to cotangent. Oh, constant. I'm sorry,
Constant, right? Yeah, we'd think of that top left as being the first thing on the page. What would we normally think of being as the last thing on the page?
Cotangent.
Cotangent, the bottom right. So just having that conversation with our students helps us to take things that we take for granted. I know I tend to take for granted, right? How do you read a piece of paper that's got a lot of things on it, and help our students to go, oh, what order do I look at these ideas? Right? So there's a way that we can be overt in how we're reading through things and talking about order instead of just letting them sort of pick it up along the way. The blue bar down the side is another way that we can express order. So we can tell that. We can ask our students, well, what do you think is the order on the page important? Not just in this page here, right, but on any page, right? What does the order of things on the page tell us? And I would really encourage you, if you have students that are becoming more familiar, if this is going to overwhelm them, don't. But if you have students that are becoming more familiar, compare the order of lessons 25 and 26. The two lessons were very intentionally designed to share a common order. So there's a lot of similarities between 25 and 26. And just looking at the order of the lessons, the order of the charts, just looking at those is going to help your students to see the connection between the idea of the derivative and the integral, even before they really understand what it is. But they're going to be able to see the similarities in the order between the two lessons. And again, remembering that the goal is to practice relationship, not necessarily the math. The math can become a great resource, but our primary objective with these pages is to practice the skill of relationship, or any of the other common topics. This week, we just happen to be talking about relationship.
It's also a good time to put in a different way of approaching the math map. So if you have a student that wanted to do 25 and 26 together over 2 weeks, so they could see that similarity, that would be another way. So page 1 on both of them have the same problem, done different. One's integrated, one's derived. And so you could do it that way also, to see that there's relationships across the booklets.
Any questions about common topics or I-squared page? Looking at day 2, notice we have the same order. So we went from our constant to our linear function, and so we're looking again at those same functions in order. But as Lee just said, where last week we were looking at the derivative, this week we're taking a look at the integral of those functions. Last week, when you worked through that lesson, you'll notice that calculating the straightforward calculations for the derivative follow a rule. Then we practice it and practice it and practice it in lesson 25. In lesson 26, we're going to see the reverse order is true, that there's a pattern for those power functions that we can practice over and over and over again to see how to calculate those. Are there any questions from this page?
Something else I thought of you can do, because Kirsty and I did it, is let's say you have a student that's transitioning and because of the tracing and there's very little work to do on these pages, you could ask them to go back to week 11 and find these same 16 problems in each of the booklets that they're in, either in the I pages, in the lesson set, in the chart, or in the work pages like here. So they can see that, oh, it's always the same 16.
Is this the first time we will see on monomials the Riemann sums? I don't recall other books.
So they are, so let's take a look at the next, when we get to page 3, let's talk about what that's going to look like. So on day 3, we take a look at our IQ, Memoria, and arrangement page. We're practicing our 5 core habits of Memoria. And this week are talking about, not necessarily restricting that to this week of the lesson, but we're talking about attending. And when I think of attending, it really means being present. If we take attendance, we want to know who was present. You know, as a mom, sometimes it's a little bit more difficult to be present, right, where I am, because I'm thinking about the soup that's on the stove or the laundry that needs to be changed into the dryer, right? Or all the different things that are going on. So in my mind, I have all of these things going on. So I'm not necessarily present in that moment. And so when we talk about the core habits of Memoria, what we're saying is that if you want to remember something, you've got to be present. You have to be there. And as hard as that is for moms, right? Sometimes that's what we need to practice is attending, being present, staying there where we are with our children, reading things carefully, helping them to find the patterns, and not trying to think about the 10 other things that we have to do. That's probably right. When we think about attending, there's probably more for us to learn than our students. But as we learn to be present ourselves, I think that that's going to help our students learn to be present in their learning. And as we're present, we start to read more carefully. We start to look for patterns. We start to notice things because our attention now is where we're at and not on all of the other things that are around us. And specifically helping our students when we have tables, I always think that with our youngest students, helping them to read and decipher a table is really important. And that's one of the things that this page gives us lots of opportunity to do, is to look at that table and talk about, okay, at the top it says name of parent graph. What's in this column? Well, constant line. So what is constant? Oh, it's the name of the parent graph. Helping them to see how to read those columns or those rows. The rows are a great example because some of them are power functions, some of them are exponential functions, some of them are trigonometric functions that we're using that sideways bar there, which as adults, we all understand how to read, but this is a great opportunity with our younger students, right? What does it mean when you see that all of these bars have this same, right? So sine, cosine, tangent, they're all have this same trigonometric function. That means it applies to all of those, helping them to see that. For those students who are becoming more familiar, a transitional right towards them finding their own patterns is to ask questions that help them find patterns. Asking them, well, what's different from the left column where it says derivative in the right column where it says function, right? What's one thing that's different? Oh, well, the A is still there, the H is still there, the X is still there, but the K is gone, right? We can note asking them what's different is going to help them to start learning how to look for patterns. when we ask those questions. But now as we look here at page 3, you'll notice that Lee is looking at still estimating those shapes in our younger ages, but you're correct with monomials. We're now using Riemann sums, and the students are actually starting to calculate those Riemann sums. They are what I would call very simple sums because we're using a unit width. We're not asking them to make those very narrow and calculate, but we're using those unit widths there. But we're introducing the idea of the Riemann sum as a way to estimate our area under the graph. And then in time, they're going to start to see that the Riemann sum becomes or what the limit is that we're looking at when we look at integral calculus. But
So
the
this is the
great thing,
first. So this is the first time that the Riemann sums are introduced. And will it
yeah,
come in other booklets like come in the future, like set 27, 28? No, not 28, 29.
no, you're just going to see Riemann sums are only going to be in lesson 26. But
Okay.
I think, and I'd have to go back and look, that I think Lee does introduce the idea of the Riemann sums in the narrower domains, but in a very simple way, mostly the left, right, middle type of question.
Yeah, that's right at digits. We begin introducing them.
So they've seen the
This is the
name.
only, but this is the only booklet that they practice the
Yeah.
problems in. Yeah.
Yeah. Okay.
I think Riemann sums are a great way if you have a student who is pushing you for something more, is to say, okay, well, what would make this a better estimate? What if my columns were only half a unit? What if they were only a quarter of a unit? And then let them think through that and ask those questions without making it a big calculus study, but just saying, okay, we're looking at using rectangles. Well, what would make it a better estimate? Well, a narrower rectangle, I could fit more in. That would be a great way if you have those students that are kind of pushing you, they want something a little bit more. That Riemann sums, I think, are a very accessible way to do that with those students.
I think one of the questions like they probably will ask me how to define it. So definition of the Riemann sums. What is that? And who is Riemann? And so we can go through a historic study on that.
There's so much, isn't there? There's so much to. I was just reading about Cantor, really that anxious to get communicated. Not that he was still really the big mover behind the whole ideas of infinity and everything else, but he had a correspondence with Dedekind, who was much more slow at his work. And so as they were communicating, and Dad would give him some hints or improve upon Cantor's work, Cantor would turn around and publish that without giving any credit. And they've just recently found evidence. They thought that had happened, and they've just recently found evidence that it did happen. And so not that Cantor plagiarized all of his work, but that he wasn't very good about giving credit where credit was due in some cases. And to me, those stories behind the people just make it even more interesting because it makes it so much more real that these weren't just people sitting in ivory towers thinking big thoughts, but they were flawed people that God chose to reveal wisdom to give to us that we could all build on it. And so we are also flawed and we can work hard, and God might choose us to give wisdom to.
Mm-hmm.
Yeah, it just makes that feel a little bit more possible.
Who was the guy's name that you said? Because I didn't catch the beginning of it.
Georg Cantor, Cantor.
Okay.
He was really credited with the early work into infinity. And one of the big things that at the time, there was sort of an acceptance that infinity got really big or really, really big, either positive or negative, right? That I could always add another number or I could always subtract another number. People sort of agreed with that. But the idea that there was an infinite number of numbers between 0 and 1, or between 0 and 1/2, or between 0 and 1/4, or between 0 and 0.1, that the idea that infinity lived in there was not as accepted. And Cantor was really the one, and it was his ideas. I don't want to take anything away and say he stole the ideas. He he had help clarifying the ideas that he didn't credit, but he was the one that really talked about that. And one of the things that the quotes, well, it was a paraphrase, and so I want to find where he wrote it, is that he talked when he saw this and he said, look, there's this infinity in the smallest parts of the number line. And he said, it's proof to me that God is all around us, right? God's not somewhere out there just at the ends of our number line, but he's here, right? Between 0 and 1, or between 1 and 1.01, that there's an infinite number of numbers there. Georg Cantor saw that as this evidence that God was all around us and inescapable. So anyway, sorry, a little bit of a rabbit trail there, but on day 4, we always like to talk about our careful calculations page. And I chose this because it does match what we're doing this week on our careful calculations page, but it's a strategy that can be used any week. And that is using your careful calculations as a place to practice memory work. So you can either consider elements that you have previously memorized and ask your students to name or identify those in the memory work. Or if you look ahead to your careful calculations page, that might help you pick some things that you want them to memorize or practice that week. And then you use the I-4 page as a quiz. Did you actually do the memory work that I asked you to do? And this week, memorizing these integrals is largely initially going to be memory work for our students, right? That we can all memorize those integrals and those derivatives. We don't calculate them every time, that we memorize those, and then we use those basic integrals in order to calculate more complicated expressions. And then that brings us to our page 4. And here you go, Yatin. You can see this is where we have approximating the definite integral, and we haven't used the name here, Riemann sum, but that's what we're seeing, is that we're getting these rectangles and we're practicing the idea of whether it's left, middle, or right. And so we're practicing the grammar, we're practicing the idea that goes along, so that eventually the student is going to connect the idea of these rectangles being added together as the Riemann sum. Mm-hmm. Any questions from page 4? Just a reminder that we have 4 weeks left of our book club this year. We would love to invite you to either bring or share a testimony that would be how you have seen truth, beauty, or goodness this year. Essentially, something you would include in your lesson 29 booklet. So I really want to encourage everybody to share that with us. I think that's an encouragement to us all when we see how everybody is seeing math and God in the world around them, God in their math, and so forth. And so we've got our 4 weeks left. Lesson 27 is our complex number week. Lesson 28 is proofs. Lesson 29 is when we'll share our testimonies. And then lesson 30, we'll be taking another look at what does it mean to reflect back on our work, and how can we take that reflection as a guide to what we might want to do over the summer. We had one question that came in this week that I thought was would really be helpful for us to talk about today. And that was, does the math map count as algebra? And it was specifically asking about monomials, right? Are we learning algebra? And as I pondered this, I thought that a lot of the times when we think of algebra, we limit it in a similar way that when we think about math, we limit it by just thinking about computations. That when we say do the math, what we usually mean is to go and add, subtract, multiply, or divide. Do the calculation and simplify it. That's what we mean when we say do the math. And so we immediately take this whole branch of thought, of study that has the potential to lead us to eternal truth, right? That's what the ancients believed, was that math was what we had to study in order to have access to eternal truth, that we discount so much of that when all we think of are the operations. Similarly, when we think of algebra, oftentimes we think about algebra computation and we think about solving equations. And when we do that, we are limiting what algebra really is. And so when we think about algebra, it's very generally all of the laws and the processes that work for arithmetic. And when I say that, I say what I mean is, what are the things that are always true, right? So algebra is our sort of first step on that journey towards determining what is true. So I could add 2 and 3 and get 5, and I can add 5 and 3 and get, or sorry, 3 and 2. I can add 2 and 3 and get 5, or I could add 3 and 2 and get 5. I could add 6 and 8 and get 14, or 8 and 6 and get 14. And I can keep doing that and know that that's true. As soon as I say any two numbers can be added in any order and it doesn't change the sum, that's algebra. Because I've gone from numbers and concrete examples to a general case that holds for every number. As soon as I say, it doesn't matter if I say 1 plus 2 first is 3 plus 3 is 6, or if I say 2 plus 3 is 5 plus 1 is 6, right? As soon as I say for any three numbers, the order in which I add them doesn't change the sum, then I'm talking about the associative law and I've done algebra. So does the math map count as algebra? Yes, because we talk about the commutative law, the associative law, the distributive law, and others. When we talk about symbols representing numbers, all we're doing is we're saying, okay, if I have a symbol, and it doesn't matter if it's an apple or a triangle, if I'm using something to represent it's a general case, right? That's why we use letters, is because we're saying X can be any number. So instead of saying 2 plus 2 equals 2 times 2 is 4, and 3 plus 3 is 2 times 3 equals, right? Or instead of going through every number and saying that when I add the same two numbers, it's the same as 2 times that number, right? When I go, well, X plus X is 2 times X. I just said that relationship holds for any number. That's what the letters do for us. That's what the symbols do for us. Does the math map have students working with symbols to represent numbers all the time, even with our digits, right? So yes, we're seeing that. Graphs and equations that represent relationships. Again, that's a big idea of algebra, is we're saying I can have this graph or this equation, especially when I have two variables, is telling me about the relationship between these two sets. That's a really big idea, but notice, what do our students do? We just talked about it, that by the time we get to lesson 26, they're going, I've seen this constant function, I've seen this linear function, I've seen this quadratic function, I've seen these graphs over and over and over again. That is all algebra. And so those algebraic concepts are being practiced, right, in 4, 5, 6, 7, and 8. Those are where we're learning the basic laws. We're looking at computation in 4, 5, 6, 7, and 8. We're looking at some of the key functions in 11, 18, 25, and 26. And I'm pulling these out here because if we were to look, I happened this past week to look at college algebra syllabi and what is covered in college algebra. And college algebra is basically our lessons 11 and 18. College pre-calculus is basically our lessons 16, 18, maybe 25. Right. So when we think of algebra, is the math map covering that? It absolutely is. We're looking at processes in 18 and 17 and 19. We're looking at the relations in 13, 16, and 21. So we're looking at the grammar of algebra. Now, through monomials, no student will have done so much algebraic manipulation and computation that they're fluent. That won't have happened yet. It will, give them another 3 or 4 years. They're going to build that fluency of computation, right? So if you happen to be a challenge 1, 2, 3, or 4 parent this year, and you're ahead of the curve, you were an early adopter, and all you have is monomials, right? It may help to do some supplementation to practice using that algebraic computation. But the concepts that students learn, you are absolutely getting all of the concepts, all of the language, all of the grammar it through the math map. And so I just wanted to encourage people that are wondering about that algebra is bigger than solving equations. That's just one of the tools that we use to examine these relationships within algebra. So,
I really,
Okay, well, can I add first, Yading, and then we'll hear you? So I want to read you something. A lot of folks are aware of the fact that America is a lot younger than Europe. And so we took a lot of our classical educational ideas from the Oxford and Cambridge model, which are taught across the globe. So I want to read this to you. Unlike the US system, the UK does not use standardized course titles like Algebra 1. Instead, content is integrated across key stages and qualifications. So this is another thing that makes us classical that the modern mind's going to have to wrap around. So thank you, Kirsty, for all that information. It is everywhere. Okay, Yading, your turn.
I want to attest to that because I grew up in Singapore, and Singapore uses the O level and A level in the UK system. And so I've never had experience or reference point of American school. So all these parents that say, oh, I dropped out of algebra 1, I stopped after calculus 1. I'm like, what? I have to really rethink, because we put a course title and it only encounter algebra in high school. But from what I'm growing up, that didn't quite make sense to me. But as I'm actually talking to these parents, and you had said that if they are the early adopters, like, if I have a child in challenge 1, this is the first year in math map. He only have 4 years of repetition. So while we really envy the natural students, the digit students, because they have 13 years of repetition, so that by then, by the time of when they graduate from high school, they have so many rounds of practice. When do you think would be the lowest domain or the narrowest domain that parents should add some types of supplements in order for them, if the end goal is college? Because I have clients that I'm advising. Do you think you should add in challenge
so
A? How many
no.
rounds? I guess a
So if
question is, how many rounds of math map built fluency? It's enough to
well,
build fluency.
so so I think the first thing is that we have to acknowledge that it's different, right? We are looking at algebra differently. And where the traditional modern classroom system emphasizes being able to use the tool it doesn't necessarily emphasize having the language or developing the underlying understanding of the content. So if a student, let's just think about this. If a student went through Algebra 1 and Algebra 2, they have 2 years where they may see some overlapping ideas, but they'll talk about exponential functions for maybe 2 weeks. They might talk about logarithmic functions for 1 week. Throughout all of that, they're going to be doing basic algebraic computation, but they're hitting on these ideas for a week or 2 weeks, these basic ideas. The math map, you're going to see the idea behind powers and exponential, right? We're going to talk about it in 1D, first of all, in lesson 7. You're going to see it in lesson 11. You're going to revisit it to some degree, a little bit in 17, although not as much, but definitely 18, you're going to look at those functions. You're definitely going to be looking at some applications of those functions in our rate unit, and then in 25 and 26. So in 1 year, I'm going to be talking about the exponential function in at least 1, 2, 3, 4, let's say 5 weeks. And if I do that just for 4 years, that's 20 weeks where I am going to talk about what the exponential function looks like as a graph and what it looks like symbolically. Now, am I going to, in 1 or 2 years, become fluent at solving an exponential expression for the roots? Maybe not in a couple of years. I think that for students who are, let's say in challenge 1, they're using monomials. I think if they keep going for the next 3 years, I think that they'll get to that point, right? By the time they graduate, they'll miss out on transcendentals, but they'll get polynomials and expressions, and they'll have the opportunity to solve some of those. Will they get the same? It won't be the same practice you would get in a traditional text because we're practicing more, right? We're practicing the language. We're understanding what it means that it's a transformation, that what the parent function is, what the derivative and the integral are. We're attaching a lot more meaning to that exponential function and not just how do you solve for the value of x. That's just, right? That's one small piece that your traditional education practices a lot and a lot and a lot. We're saying, here's the whole picture. That's just a small portion of it. For most students who want to go to college, and I'm most students who want to go to college and are not planning to go into a STEM field, I don't think you need to add anything into the math map, even if you're an early adopter and you're not going to get all the lessons through, right? If you have a student who is very desirous to go into a STEM field, I don't think you necessarily need to supplement a lot. But you may want to have a little bit more practice of, the summer would be a great time to practice. Just go back and multiplying binomials so that you get fast at it, right? That's the benefit of drill sheets, is that you do the same thing over and over again and you build up some fluency. So if you have a student who plans to go into a STEM field and you're saying, what should we do over the summer? Well, there's some ideas, right? Go practice that. And I would tell people that want to go into a STEM field, even if you've done a traditional curriculum, use your summers to build your fluency of algebraic manipulation, of multiplying binomials, of multiplying trinomials, of factoring. Factoring is one of those things where there's a little bit of an art to it, where you have to see the patterns and right? That comes from, I've done this a lot. So the math map is going to really equip them to know what patterns to look for, what's the language that I'm doing. actually seeing the patterns comes from a lot of practice. And so if that's something that you think you want to prepare your child for, then there's a place to specifically practice, right? Just as if I was going to send a student off to culinary school, I would want to make sure that they really had their conversion factors down, right? Can you convert between ounces and grams and pounds and teaspoons and cups, right? Can you do that really, really well? Because if I'm going to culinary school, I'm probably not going to be solving a lot of algebraic equations, but I need to know, right, how to work with fractions and I need to know how to convert my things. So as we're preparing our students, obviously God is going to make sure they have everything they need. I believe that the math map is the best, well-rounded curriculum that is going to prepare our students for whatever it is that they want to do. If you have specific niche things that you're like, oh, I really want them to be able to factor a quadratic, right? Well, go practice that, right? If that's a skill that really matters to you, then practice it. Just like if I say I really want my child to be able to cut with a saw in a miter box, I'm going to have them go practice that particular skill. But I would want them to understand why, right? So the math map is the why, it's the big picture. It's going to provide enough practice for students to be well prepared for whatever they want to do. If a parent has specific goals, then you can hone in on any of those particular goals. I don't know. Does that help answer that question?
Absolutely, because that's one thing that as a book rep, when we're trying to talk to our families, is that to help them understand that don't fall into the either or fallacy, right? Go practice in the summertime. Math map is 30 weeks, and depending on what your child wants and what they're honed into, so you can tailor up, tailor down, tailor left, tailor right, and and so that gives a lot of freedom. Thank you, though, because I know my family's asking that question.
Something that's interesting to me philosophically is that people ask, well, it's not just math, Latin, the literature, history, all that, all those things, as though the system they're comparing to, the US system or the UK system, as though they're working. They're not working. That's why people are pulling their kids out and are homeschooling. So we need to ask, because how we think, we need to ask from what we know. It's right that they ask these questions. But trying to fit this into the very thing they're escaping is not very helpful. So these were all excellent explanations. So thank you.
Thanks. That was good, and I think that'll be helpful to a lot of people to hear that, right, and to think, and just yachting the thought that when you said the either or, right, that we think somehow that every child needs the exact same math, right? So if I was going to pack a suitcase, I'm not going to pack a suitcase that's exactly the same for every child. There are going to be things in there. I'm going to make sure that there's socks, that there's underwear, that there's some bottoms, that there's some tops, right? But depending on where you live or where you're going or the types of activities you're going to do, right? You might need to tailor your packing. And so education is the same way. The math map is giving you, I think, of any curriculum that I've seen, is giving you the broadest, best foundational understanding of math that really can, when we keep saying Matthew 6:33 says, seek ye first the kingdom of God and his righteousness, and all these things will be added to you, that when we're shooting for our children to be walking with the Lord, doing what he's has prepared for them to do, the work that he's prepared for them to do, the math map is going to give them the foundation for whatever that looks like. And then trust the Lord to lead you to those extra things, those special things, right? So I've packed my suitcases, all of the basic things, right? And you say, well, we're going on a cruise. We're definitely going to need bathing suits too, right? I'm going to add bathing suits to my kids' suitcase. Whereas Babs might be like, well, we're going skiing, so I'm going to make sure that we put snow pants in, right? And then you hope that your luggage doesn't get switched, right? That we can start with a broad foundation and then we tailor where we need to for our kids and where the Lord leads. Are there any other questions that anybody brought today? That was a good one. Well, I always enjoy time with you all. Your faces are precious to me, and it is always a joy to see you join us. And for those of you who watch us on a recording, know that we pray for you too, and we're grateful for you too. And we're again, I know I say this often, but it is an investment by CC to make this resource available and to invest in the time to be here. That Lee herself is here is a huge investment that CC is making in families because they want you to know that you can teach math, that you can lead the math in your homeschool. You don't need to outsource it to a video. You don't need to hire a tutor, that you can lead math education in your home. And so I'm ever grateful for the opportunity to speak together every week. So thanks for being here and have a great week. And I look forward to seeing you next week.